So you've seen there before you went out for interval, one or not, but how you are presenting the work actually can guide you as to how you are going to look for your answers. And you can go now use yes, there's a lot of ways, right, in determining certain stuff, but in mathematics, we need to be proficient in not only getting to the answer, but also how you get to the answer. And that's why time is such a big constraint for us, because we know all of the work, but we don't know our work well enough to choose the right method and to know exactly when to choose the right methods. So you can turn the page now to page 2. There's some basic algebra questions. I'm going to give you a few minutes to go through those questions. If you have any questions there, just raise your hand. I'll come to you. But this is supposed to be straightforward questions, and then we can look at the answers in a few minutes for page 2. Okay? These are the backbone of the work, of all of the mathematics that you're basically going to do for the year. Page 2, girls. So the idea of today's session and yesterday's session is actually to provide you with some clarity and also with the stuff that you are struggling on. Yeah? So I would like you to work. It helps me to see where you are encountering some challenges. So what I'm going to do, I'm going to allow you to work through the work. You will see it's much easier working through paper 1 work as it was yesterday with paper 2. Can I have everyone's attention here quickly? So I'm just going to mark with you and also provide you with some tips and what is the theory behind this, right? So let's look at question number 1.1. It says the x minus 3 and multiplied with 2x plus 1 is equals to 0. Straightforward question. Let's discuss what type of question is this, or what basic underlining principle would I use there. I'm going to take it back to algebra, or not back to algebra, but to a basic concept of A times B is equals to 0. And that is a grade 9 concept, which we call a zero product. So either the one bracket is equals to 0 or the other bracket is equals to 0. So if, what is the two brackets there? X minus 3, 2x plus 1 equals to 0. So you could have said here x is equals to 3, or x is equals to, you take the 2, there's 2x, negative 1, you take that, and there's your two answers. 2 marks only going for there. So you didn't even have to include that step there for you. Simple like that. And that is questions like these that we cannot afford to get wrong. That's the idea. So if you got that, pat yourself there. Like the younger generation would say, clock it. No, don't know what that means, but okay. You do whatever makes you feel good. But that is also the how you should feel when you do mathematics. So next question there is a quadratic trinomial. First one there is, this is 1.1.1. 1.1.2 is, we should do what? So if now I gave you the method, no, not the method, but the theory behind it. What did I say now by number 1.1? Zero product. So you're supposed to write it down. If you haven't, I write it down, highlight it. Then, because when you are studying at number 1.1, at number 1.2, you should identify this is actually a
zero product. No.
quadratic what? Trinomial. So what is the steps when we're doing a quadratic trinomial? You make sure it is in standard form. So there's two things to write down. Quadratic, you identify it is a quadratic trinomial. Make sure it's in standard form. So standard form will be the second one. So I'm going to do it in standard form. That's going to be x squared plus 2x. I'm bringing the 35 over, so it becomes minus 35. Now already learners make a mistake there because they forget the sign change. And you know I say that is when we are marking, because your first mark already goes for that one. Then We can do this by the quadratic formula, or we can do it by simple factorization. Because this one is simple, I'm going to take the factors of the first term, and for those grade 12s who will be watching this video, because I'm sending it to you, we take the factors of the first term, the factors of the last term, no? As we were taught in grade 10, or in, some of us were even taught this in grade 9 at other schools. You take the factors of the first term, which is x and x, you take the factors of 35, which is 7 and 5, you cross multiply, I get there 5x and 7x. The idea is to get to the middle term, so negative 5 and positive 7. So that's a positive, there's a negative. These two stuff becomes your brackets. So that's x plus 7 and x minus 5. And therefore, zero product, x is equals to negative 7 or x is equals to positive 5. Once again, if you got those questions correct, clock it. No? So now that is how we start scoring marks in a question paper, and especially question paper 1. These are standardized question papers, which I just took these questions from question papers, past papers, and we are working through them now. The next question there is now 1.3, 1.1.3, 2x squared minus 3x minus 3 equals to 0. But correct to 2 decimal places. That is supposed to give me indication, which tells me, so now you highlight correct till 2 decimal places, quadratic formula. So the first thing that I'm going to do for myself is I will do at 1.1.3, I'll write down the equation. We have 2x squared minus 3x minus 3 equals to 0. The first thing that I will do is I will go determine delta, or the discriminant, and I would say the formula for this is equals to b squared minus 4ac. Why do I do this? If this is negative, I don't even have to work any further. Then I can show immediately that there is no solution. Okay, so I'm going to work out this. First, I'm going to say negative 3, check the using of brackets, minus 4, a is 2 times with negative 3. Do you note I haven't touched the calculator yet? 9, negative times negative is equals to a positive, so it's 4 times 3, which equals to 12, times 2 is equals to 24. 24 plus 9 is equals to 33. So now I know that that is actually going to be my answer of the square root. And now I can write down my quadratic formula, which comes from my information sheet. And I have a little bit adapted form of this. So I just negative b plus minus the square root of the discriminant or delta over 2a. Don't have to write this down again, but it's good to write it down so that you don't make a mistake in substituting. So therefore, I'm going to say x is equals to negative b. So now you see a negative times a negative is equals to a positive, plus minus the square root of 33 and over 2 times 2, like that. No? And we know that answer is 4. I can go to my calculator, punch this in, and then I get an answer 2,19 if I round it off to 2 decimal places, and then or x is equals to negative, 669. You see your standard types of question. Now the next question, those of you who got that answer right, well done. You can, or sorry for getting, let's first, if you got these two answers correct, once again, pat yourself. The next question is some interesting work. Now normally, and you can expect, when we put in work that has not been covered in class, is either considered as level 4 type of questions, or it can also be considered as enrichment. Okay, so in maths there's not only one way to get to a answer. Let's look at this question. 3 to the power of x is equals to 1700. Looks like a standard type of question, but how are we going to solve it? It is in the exponent. Okay, let me try and get another question. Let's compare this question. Let's do 5 to the power of x is equals to 125. Let's keep it simple. How would we go about this question? We would prime factorize this. This is a grade 9 type of question. From the eye, they look quite similar.
Yeah.
No? So how would we go about this question? We would break this question down. So that's going to prime factorize 5 to the power of 3, 5 to the power of x. Bases are the same, and therefore x is equals to 3. And we can test by substitution. My left-hand side is equals to, if I substitute here x is equals to 3, I get 125. If we prime factorize 1700, we don't get a perfect prime base of 3. Okay, and also the question says correct till 2 decimal places. So we are mathematics students, we are grade 11 on the verge of grade 12. Let's apply our brains. No? Let's apply our brains and let's do this let's use a calculator to see if we can perhaps figure out a way how to get to an answer. I need everyone's attention here. Now, because I'm first going to explain and then afterwards we can look as, isn't there perhaps an easier way? So let's think about this question. In an exam, you don't have this much time to think. You need to do more exams, but that is why we're having this session today, so that we can think about the questions. If we have question like this, no, and let's think about the theory of this question. 3 to the power of 0 is equals to 1. 3 to the power of 1 is equals to 3. 3 to the power of 2 is equals to 9. 3 to the power of 3 is equals to 27. And so I can go on. But I actually want to get close to that value. So this is now called inspection, which is also a method of how many mathematics was discovered, or many theories of mathematics was discovered. So let's try 3 to the power of 5. What is 3 to the power of 5? You can use your calculators. 3, 243. 243. Let's multiply with 3 to the power of 6, because we're not close to that number yet. 729. 729. Let's try 3 to the power of 7. 2187. Okay. So we've done inspection, we've thought about the problem. Yeah? So we can see it's between these two numbers, but we're not concerned about the threes, but we need to isolate them. So we can say, okay, 3 to the power of x needs to be less than 3 to the power of 7, but it needs to be greater than 3 to the power of 6. Okay. Now, if we go plot this in a number line, is it closer to this number or closer to that number? To the bottom. No? So let's do some inspection. Let's play around now on our calculators. Take your calculator. Let's try now 3 to the power of, you say it's closer to 7. So let's try 3,68. Sorry, 3,68. Close, no? Okay, but we are above.
Yes.
Let's try 3 to the power of 6,7. Still not less now. What is the answer?
1572.
1572, and we want to be at?
Above.
Okay, let's try 77. Hold on. We are formalizing now things. We're not there yet. Getting close. Let's try 07.
Oh, really?
Are we getting closer?
Yes.
Okay, then you round off, but we don't like rounding off in mathematics because we don't. If we round off, we almost categorize you as one which you are not. Oh, let's go on and let's say 70708.
If I add 1, it's 1.7.
That's not exact number. It's still in the commas. Let's try this number and then let's try 04. Is it? Are you sure? Try this number then. Try that number. I know. How did you get the answer?
In a line.
How did you get the answer? How did you get that whole thing? Get you to the answer. Then you probably didn't type it right.
Let me start with 1.699. And then the one just talking about is this one. Oh, or I didn't put the 0, that's why. So remove the 080. Because it's 80. Or it's 84.
80.
Yeah, remove the 0. There we go. You know, John. There we go.
So we have the complete answer, but they ask us to 2 decimals. 1 decimal? 2 decimals. So we can now say 6,77. That is the answer of x. But that now because there was that. Now I need you to listen carefully. And this is now introduction to a new topic, which when we have something and we don't know the answer and we cannot find a base that's equal, then we can go to log. So I want you to page back quickly to log.
This log. Page back to log.
Page back to log. So log says, and that's why you are here grade 11 to learn of the grade 12 work. If I have something to the power of something and I have a answer to that, I can rewrite this in log. No? So then this is going to be log of the, and then the base as the answer, and then I'm getting the a as an exponent. Did I write it down? Yeah. This is a, y equals to y. Let me explain this then. All right. That is the definition. This is the formal definition of log. No? So I'm going to get back to the question again. But this is now how mathematics works. So we ask the question, do I need to do this in exam? Am I going to do this? You are sitting with a problem. And that's all of the stuff that we've been doing, is basically based on mathematical principles. So people have sat with problems and then they say, okay, but that's going to take us too long. Isn't there a shorter way? And then they go and discover, okay, how can we do this? So I'm just showing you a glimpse of a new topic, which is now going to be logarithms, all right? And how this can be used to solve a difficult question. So when let's discuss quickly logs. I'm going to try and teach you the basics of logs. So when we have, let's say, let's go to our calculators, and then you're going to type in your calculator log of, let me just see. So you're going to type here. No, you're going to press you're supposed to give you, if you type in a calculator, make sure you get this one, and it gives you that one. No? So it's shift and then log. Okay?
You just press the shift. Look, there's two logs, sir.
The one underneath is shift. So remember here, we're gonna play around. I'm not gonna tell you what it is, but I want you to discover quickly. So if we press now log, and then here you're gonna put down a 2, and there I want you to put down an 8. Your answer is supposed to be 3. Let's discuss. 2 to the power of 3 is equals to 8. So what do you think if I change this number to 16, what is this going to become? So this is the base, and this is the answer, and this is then the exponent. So to solve logs, you basically say the base of what is going to give me to 16. So if I go rewrite this question, okay, everyone got it now? Wonders, no? The base of this question is now what? How can we ask? How can, instead of doing all of this, running through this process, because I took you now on a 20-minute journey, no? For 3 marks. So how can we rewrite this to get to the answer? All you have to say is now log of 3, 1,700 is equals to x. And there's the answer right there.
You see?
Do you see? There's not always time if you don't allow the teachers to teach. Because if you keep on asking questions and you want the immediate answer, you're not going to allow the teacher to teach. And then you're not going to discover what we wish to teach you. But you can discover logs without the calculator as well.
That's all.
No, you must not going to do this. This is the answer. But now you write your answer down. X is therefore equals to 6,77. And so you get the answer there using for logs, and your final answer is for rounding correct.
Must write log.
No, you don't have to write log, but you have to figure out the answer.
Or like standard deviation. Once you get the right answer, you'll know. Okay, this one.
Yes, you can use anything in maths. But listen here, guys. Log is a grade 12 topic. No, it's not a formal grade 12 topic, but we can get to teach it. But you've already done now the basics of logs. So now you have an idea of what you can expect. So, and the things that you are learning can be helpful, but if you don't understand the complete foundation of everything, you're just going to be in the air. Now you know logs. Now I put you in the air of log, And now you're going to think, no, that is a log question. Everything is not a log question. No? The rest of the questions are simple questions. So, but I just want to show you, if you allow stuff, and that is why mathematics is such a beautiful subject. You never allowed me. That is why you are here today. You can now go on, guys.
Good question. Isn't it easier way? I'm serious.
It just takes practice. And it's gonna then when you have a lot of practice, you're gonna start seeing the answers just like that. Convert it to log. Now you're gonna get it right. Question number 1.2. That's simultaneous equation. Where did I put my booklet now? So 1.2, let's quickly look. Solve for x and y, given that both satisfy the equation simultaneously. This is a simultaneous equation. Can I get everyone's attention? When you get the simultaneous equation, please make sure that you choose the easiest equation and make x or y the subject if it's not already. So in that first one there, we are given x plus y is equals to 5. What is the subject here? 5 is the subject. So how do we make anyone the subject? I'm going to make x the subject. So then I just say 5 minus y. Then I rename this. This is still equation number 1. Then I'm going to say substitute equation 1 in equation 2. Simply like that. Okay? And I'm going to do exactly that. So what is equation number 2? It is x, but x is what? 5 minus y times y is equals to 21 minus x squared. So that's going to be, once again, 5 minus y, close the bracket, square. Make use of brackets, learners, and then minus y squared. Then, what is our next step going to be? To distribute or... So I'm going to multiply 5 times y, which equals to 5y. Minus y squared equals to 21. And then I'm first going to do this one. All right, I'm going to keep the bracket. So I'm going to say this is a binomial squared. So that becomes 25 minus 10y plus y squared minus y squared. Now I'm going to distribute this negative. Please take your time. And then I'm going to say 21 minus 25 plus 10y minus y squared minus y squared. So that gives me, let's bring this to over. So I'm going to leave a 0 here. Plus y squared minus 5y. Let's do the y squares now. Negative 2y squared plus y. So that's negative y squared. Let's do the y. Plus 5y minus 5y plus 5y. 21 minus 25 minus 4. I don't like working with the negative, so I'm just going to take everything to the other side. So that becomes then y squared minus 5y plus 4 equals to 0. And then factors of the first term, factors of the last term. To factorize, I get y, 4 and 1 minus minus. So therefore y is equals to 1 or y is equals to 4. You don't have to show the next steps, but now we're going to say sub y equals to 1 in, I'm going to choose the easiest, in equation 1. So therefore I'm going to get x is equals to 5 minus 1, which equals to 4. So there's my answer, where x is equals to 4, y is equals to 1. Here's my first set of coordinates, and then I'm going to say sub y equals to 4 in equation 1. So then I'm going to say x is equals to 5 minus 4, which equals to 1. So x equals to 1, where y is equals to 4. These are two sets. I'm going to go on now. Let's read the one. This is grade 12. No? Let's read that one. 1.3. If x is negative 4 is 1 root of 2x squared minus mx minus 12 is equals to 0. Show that the value of m is equals to negative 5. Now, these questions normally confuse learners. No? Even the grade 12 learners are confused. I'm going to show you how to do it now because they give you everything that you need. So, 1.2.1, they just say 1.3.1, x is equals to negative 4 is 1 root. No? So, you're just going to take this 2x squared minus mx minus 12 equals to 0. And that is a root, meaning it's equals to 0. So all you do, you substitute a value that is negative 4. So that's equals to negative 4 squared minus negative 4 minus 12 equals to 0. So this becomes 16, 32 minus plus 4m minus 12. This becomes 20. I take the 20 over. It becomes negative 20 4m divided by 4. So m is equals to negative 5. So it's for substitution, 1 mark, and for so why can't we not? It's for substitution and simplification because they give you the answer. You just need to get the showing and the proving is a lot of these questions. So they give you the answer actually. So you know what you need to get to. No? So a lot of the times the learners read and they read over and over again, but they don't know where to put it in or where to do it. So they cannot give you here. That's why it's only 2 marks. They cannot give you for your final answer a mark because they gave you the answer. Right. So 1.3.2. Hence or otherwise solve for 2x cubed minus mx squared minus 12x equals to 0. So what all you have to do now is 1.3.2. You must already have this value. So now you're just going to say 2x to the power of 3 minus minus is equals to a plus 5x squared minus 12x equals to 0. And then great stuff. So we take out the common factor of x. That becomes 2x squared plus 5x minus 12 equals to 0. 0 product, x is equals to 0, but we still have a quadratic trinomial, which I can factorize 2x and x. Factors of 12 is going to be 3 and 4. Negative, sorry, this is a positive, this is a negative. So there I have x is equals to 0, x is equals to 3 over 2, or x is equals to negative 4. And this is a one that looks like this, where you have, let's say this is negative 4, 0, and 3 over 2. Those are the 3 roots.
So what do you do when you get home? Sleep. You don't sleep, man.
Yesterday I created this.
I can see that you don't sleep.